Welcome to my class. I'm Dr.P.Ganesh from India. If you don't subscribe to my channel, please subscribe to my channel and press the bell icon for regular update of my videos. So, in this class, what we are going to see is wired LAN network, which is also called it as an Ethernet. So generally we call it as wired Ethernet as well as a wireless Ethernet. So basically the wired Ethernet is going to be a wired LAN network, and wireless Ethernet it is going to be a WLAN network. So we all know that in computer networks there are two major data communication. One is in wired communication, another one is in wireless communication. So in this video we are going to discuss more about the wired LAN network Ethernet. So in this class what we are going to see in detail is what is Ethernet and how Ethernet is working, and then what are all the different types of Ethernet. Say for example standard Ethernet, fast Ethernet, Gigabit Ethernet, 10 Gigabit Ethernet, and what are all the different types and what is the frame format and how it works, and finally we are going to compare all the Ethernet methods. Okay, let us get into the class. Now we are going to see about the wired LAN networks, which is also called it as an Ethernet networks. So ether means it is a wired network. So this ether, it is a Greek name which is the meaning of this wired. So here we are going to talk about wired Ethernet, wired network, that we call it as a Ethernet network. So in this Ethernet network, first we are going to see what is an Ethernet protocol we are going to discuss, and then what is a standard Ethernet, because there are standard Ethernet, fast Ethernet, Gigabit Ethernet and 10 Gigabit Ethernet. So this is what we are going to see. So first we are going to talk about what is an Ethernet and what is an Ethernet protocol, and then the standard Ethernet, fast Ethernet, Gigabit and the 10 Gigabit Ethernet we are going to see in this class. So Ethernet protocol, generally this protocol which we named, which IEEE Computer Society has named this project 802. So what this Ethernet protocol which is going to define, that is a project 802 which is going to define is, this is going to talk about only the physical and data link layer, because these two layers are going to play around in either it is a local networks or it is going to be a gateway to an wide area network, so that any data communication will goes to an internet via these two layers only. Either it is going to be a wired or wireless domain. So majorly which is going to talk about the physical and the data link layer. We all know that the data link layer which is going to provide the gateway to that wide area networks, and the physical layer which is going to support for an local network. So which also going to support for both wired or the wireless networks. So this project was started in 1985, that is the IEEE Society. That project name was named as an project IEEE 802. So any other Ether networks which will have a standard number is IEEE 802.1, 2, 3, 5 and 11. So 802.11 is a very famous, we all know that it is a Wi-Fi, that is a wireless LAN network. So which is going to define about the standards and interconnection of equipment. So if I am going to develop any one equipment which is going to support for an wireless LAN, so what standard I have to follow when I am going to make a manufacturing. So in this case, these IEEE project 802 which is going to define what is the standards and how the intercommunication which is going to happen with the help of that equipment. Also which is going to specify the functions of the physical layer and the data link layer of major LAN protocols. As we have rightly mentioned that this is going to majorly discuss about the physical and data link layer, because this is going to help the data to move around both in a local networks as well as a wide area networks. So now IEEE standard for LAN we can see. For this layered architecture, if you see that either it is going to be an OSI model or it is going to be a TCP IP protocol suite, it is going to be a very common. So both the physical and data link layers. So we all know that the data link layer has been divided into two sublayers. One is a logical link control and medium access control. This medium access control, that is Ethernet MAC, which will have many types of networks, which is going to support for many type of Ethernet networks. That Ethernet networks may be token ring network, token bus network, and many more networks which is going to support in that data link layer MAC. So entire this Ethernet protocol discussion, we are going to talk about majorly in a physical as well as the MAC layer in the data link layer protocol. So Ethernet generations. So there are 4 generations as of now. The first one is a standard Ethernet, which is going to support for maximum of 10 Mbps of data rate. That is a first generation. And the second generation, which is an fast Ethernet, that the data rate will support for 100 Mbps. And the Gigabit Ethernet, which is a 1 Gbps of data rate, and 10 Gigabit Ethernet is a 10 Gbps. If you look at that, so every generation around 10 times it is going to have a 10 folds of data speed that is going to achieve in that every generation. So standard, fast, gigabit and 10 Gigabit Ethernet. So now let us start with a standard Ethernet. So we know that the standard Ethernet, which is going to support the data rate, is 10 Mbps, and then the standard format, which is going to have a standard frame format. That frame formats are going to be, which is going to support for totally the frame size is going to be 64 bytes to 1.5K bytes of data for a standard Ethernet frame format. The first 7 bytes, which is going to be in a preamble, which is going to synchronization bits, as well as which is going to identify that what protocol it belongs to. And then start frame delimiter, it is in a 1 byte, which will tell the receiver it is a start of the Ethernet frame. And then next destination address, which is a 6 bytes of address fields, and then the source address is a 6 bytes, and then the 2 bytes which is going to define that what is the length, what is the total length of a frame format, because sometimes the frame size may be varies from 64 to 1518 bytes. In that cases, what is the total length that every inter-networking device should understand. And then the rest of the field is going to be an data and then frame check sequence for error and error correction and error deduction. These are all the purpose. Error check sequence, CRC, cyclic redundancy check codes has been used. This is what the frame format for Ethernet. Now we can see that in that standard Ethernet, how the addressing going to be. We know that so every device in the network which has to be identified with the help of network interface card. So each node must have an unique network interface card, that NIC, which will have an unique address. So with that help of unique address, any datagram or data packets can be forwarded as well as it is going to receive the data. So NIC station with the link layer addresses. So this Ethernet address, that address we call it as an Ethernet address. That Ethernet addresses are 6 bytes in length, that is going to be a 48 bits, which will have an hexadecimal notation, and which was separated every two bytes, which is going to be separated with a colon between the bytes. The colon notation is going to be used. And then the access methods are going to be carrier sends multiple access with collision detection. Whatever the access control mechanism for a general LAN network, the same LAN network, it is going to be used is here. We all know that how CSMA/CD works. It is going to check the channel. If there is any other station is going to send the data, it is wait for a time. If once the station is free, the station will start sending a data. And then continuously, which is going to monitor the channel. If any other collision has happened, then immediately it is going to be detected and retransmit the same information. So the efficiency of the Ethernet also can be calculated with the help of the efficiency formula. That is going to be a ratio of the time used by the station. Suppose any one station wants to send a data, how much time which is going to use the station, use that channel, and how much data which is going to send for a time. So how much time for a particular allocated time, how much data which is going to be sent, how much time which is going to be occupied. This is exactly in the given definition is ratio of the time used by a station to send data to the time the medium is occupied by this station. So this efficiency can be calculated practically by 1 by 1 plus 6.4 into A. So the MAC address, as we mentioned that it is going to be a 6 bytes, 48 bits. So each byte will have an colon will be separated. So if you see that one example 6A, then one colon 40, then colon 60, 34 colon 38 colon and 2B. This is one example for one Ethernet address. Now we can see that it can able to support for both the unicast and multicast addresses. How it is going to identify whether this particular data is going to have a unicast or multicast. So devices which will have 6 bytes of information for first byte. For a first byte, if the last bit is going to be a 0 means, then it is going to be a unicast. If it is going to be a 1 means, it is going to be a multicast. With that help of the networking devices could able to identify that what type of addressing which is going to be used. So in practical, we can see that whenever the first byte, the first that colon notification, the byte is going to be a first byte is going to be an even number, then it is going to be a unicast. If it is going to be an odd number, which is going to be a multicast addressing mechanism. Implementation of a standard Ethernet. How we can able to implement the standard Ethernet? For example, here we have mentioned that there are two types of Ethernet, standard Ethernet we have mentioned here. The first one is a bus topology. So it is known that there is one common channel. So all the stations which is going to be connected. So the data exchange which is going to happen. And the second diagram which is going to show that it is going to be a star topology. In that star topology, common switch is going to be there. All the stations are going to be 4 stations are connected to that switch. So the data exchange will happen via that switch. And the standard Ethernet implementations are, here you can see that there are 4 types of standard Ethernet. One is a 10 base 5, 10 base 2, 10 base T, 10 base F. Now let us see in detail what is 10 base 5 and how the structure and what is the principle if it is going to use. In general principle, the 10 means which is going to mean that what is the data rate which is going to support. And then the second one is what is the technology which is going to be used. Here the base means the baseband technology, which is a digital baseband technology, and the last digit which is going to define that how much distance this particular Ethernet which can able to cover. For example, here it is mentioned 5. It means that 500 meters distance this network can able to cover. Here you can see that 10 Mbps data rate baseband technology with a 500 meters of distance. So this is what a 10 base 5 implementation. This 10 base 5 we call it as a thick Ethernet, also thick net. We call it as a thick net. So this Ethernet connection, if you see that by using a NIC which is going to connect it to that connections via the drop cable, it can maximum of distance you can able to connect from the transmission medium to your device, maximum of 50 meters. Maximum, that is the distance you can able to cover it. So overall this network can able to cover the 500 meters of distance. And then 10 base 2, it means that it is a thin net. We call it as a thin net, and data rate is going to be 10 Mbps. The baseband technology, the distance which is going to cover is 185 meters. Here the devices or nodes are going to be connected to that network via the BNCT connector. This BNCT connector is BNC stand for barrel nail connector T interface. With that it can able to connect. The distance is going to be a maximum of 185 meters only, because it is going to use a thin net, thin cables are going to be used. Next is a 10 base T. Here the twisted pair cables are going to be used here. So the data rate is 10 Mbps and the baseband technology and the twisted pair cables are going to be used. For example, there may be one switch is going to be there. So via the switch, it can able to connect the devices. And then 10 base F. The 10 base F is, it is a fiber optic cables are going to be used. The data rate is 10 Mbps and the baseband technology with the fiber optic cables are going to be used. There are two fiber optic cables are going to be used to connect to that transmission medium, or it may be a connector to the switch. So there are two fiber cables, one is for transmission purpose, the another one is for receiving purpose. Altogether it can able to support for 10 Mbps of data transmission. That is 10 base F implementation. Next is, these are all the four different types of basic standard Ethernet. Next, they want to increase the speed. They want to have a next generation. They want to have a high demand for data rate. So they want to go for a fast Ethernet. In this fast Ethernet, they have raised the speed into 10 times. It is 10 folds than that of the standard Ethernet is a fast Ethernet. In this case, how we can able to achieve that one? Because the same access method only we are going to use. Whatever the access control mechanism, the CSMA bar CD, the carrier sense multiple access with collision detection, the same mechanism which is going to use, but we want to achieve the higher speeds. So what way we can able to achieve? Why basically we can see that the first station for a regular interval of time, if it is going to send a data, either it may be a 5 Mbps or 10 Mbps, and the second station, whichever the slots are going to be free, that slots it can able to send the data. Suppose for example the first station is 5 Mbps and the second station is 5 Mbps. Altogether it can able to send 10 Mbps of data, so that the entire bandwidths are going to be shared among all other stations. So the multiple stations, for example, if the 10 stations are going to transfer the data, then each station can able to send 1 Mbps of data at a time. This is where we can able to increase it. And the next one is a network with and without bridging. For example, if I keep on increasing the number of devices in my transmission medium, so what will happen is when the number of systems are going to be increased, then automatically there will be a collision will happen. So for that reasons, they want to make it as they want to split into a collision domain into multiple divisions. So in that case, we are going to use the bridges. The bridges are going to link multiple LAN networks into a single network. So the first diagram which shows that without a bridging, and the second diagram shows the with bridging. Next is the collision domain. Identifying the collision domain and separating the collision domain. This is where we can able to increase the speeds. So without bridging, there will be a huge collision domain is there. If you are going to split into 4 sections, so the entire system is splitted into each section which will have a 3, then automatically parallelly the one section can able to send to the second, the third section may send the data to fourth sections. Likewise, we can able to increase the speed at the same time with by splitting the multiple collision domains. So switched Ethernet. In the switched Ethernet, whatever the capacity, the switch is capable of switching from one device data to another device data. Based on it, we can able to increase the data rate in that network. So each device which is connected to that particular switch, which will be considered as a separate domain. So if that particular switch a particular device can able to send in 10 Mbps of data. Likewise, if we have 10 different devices, so each devices can able to send a 10 Mbps of data speed, and 20 devices is there, so 10 devices are sending, another 10 devices are going to receive the data. Altogether we could able to achieve the 100 Mbps of data rate. This is how we can able to make it. And also the full duplex switched Ethernet. So both the transmission it can able to do, at the same time it can able to use it for receiving purpose. Here there is a possibility, suppose that particular station wants to send whole data with a 10 Mbps or 100 Mbps, it can able to accept. It means that it should be a direction, connections are going to be bidirectional. So with that help, with full duplex, it can able to achieve in this. With that, in fast Ethernet in 1990s, the fast Ethernet has been evolved, and also it can able to achieve that 100 Mbps. That means that 10 volts of the standard Ethernet speeds, which is having a also they have to be very particular about that. Whenever the new technology comes, we cannot throw it away the old existing technology. In this case, it has to compatible with an existing standards. It means that existing standard Ethernet. So here the physical layer also should support for 100 Mbps. That is where they have make it, and there is no change in the MAC layer. Without changing any MAC layer, it means that automatically the same access method we are going to use. It means that the CSMA bar CD, where the accessing mechanism only slight change with the same access control mechanism. Here the important point is, whenever we make it the minimum frame size, at the same time we could able to increase the maximum network length. That is one way it is possible. But we want to increase the transmission speed, increases into a 10 times, so that we could able to achieve 100 Mbps. So the collision domain, the deduction as well as a splitting the collision domain also, which will increases 10 times, so that the network size reduces the 10 times, so that we can able to make a fast Ethernet to 100 Mbps data rate. So encoding for a fast Ethernet, so 100 base TX, here they may be using a 4 transmission cables as well as 4 receiving separate cables. There are different coding mechanism which is they are using it. And then 100 base FX, 100 base TX means it is going to use for twisted pair cables, whereas 100 base FX which is going to use for a fiber optic cable. NRZ coding mechanism is used. And then 100 base T4, the twisted pair T4. Here in this method there are 2 cables are going to be used for a transmission, as well as the 3 cables which is going to be used for a unshielded twisted pair cables for receiving purpose. So here altogether totally which will have 4 cables. So based on the user, so each unshielded twisted pair cable can able to use for 33.33 Mbps. So what will happen is, if that particular station wants to transmit 100 Mbps data rate to send to other station, so 3 cables it can use it for transmission purpose only. Suppose that particular station wants to use it for only 50, then 2 can be used for sending, as well as 2 can be used for receiving purpose. So each cable will have an bidirectional data communication, so that it can able to achieve 100 Mbps of data rate with the help of fast Ethernet. So the fast Ethernet implementations are 100 base TX, shielded twisted pair cables are used. The maximum length is going to be 100 meters. If you look at here, when compared to a standard Ethernet, the distance are going to be less, but at the same time the speeds are going to be increased, and the collision domain is going to be have a higher level. So the 2 wires are going to be used, encoding mechanism 4B 5B plus MLT3. The same way 100 base FX, the fiber optic cable 185 meters will be used. 2 wires are going to be used, and 100 base T4 unshielded twisted pair cable with 100 meters with the 4 wires are going to be used, so that it can able all that cables are going to be an bidirectional, so we can able to achieve 100 Mbps of data rate in a fast Ethernet. Next, there is a huge demand in that network, so automatically they want to go for a higher data rate. That is where the Gigabit Ethernet protocol came into picture. But here the same address length they want to use it, the same frame format they want to use it, and the maximum and minimum frame length, they want to have it as it is. They want to have it in the standard and fast Ethernet. So the physical layer is more complicated here, because it's going to support for 1 Gbps of data rates. So the physical layer, because unchanged in that MAC layer, so automatically the complication will goes to a physical layer. So MAC will support for only full duplex. There is no half duplex communication in the Gigabit Ethernet. Up to that you can see the fast and standard Ethernet, there is a possibility for half duplex also. Even in last fast Ethernet, which will have 100 base T4 only, which can allow for full duplex communication for all the cables. So here in this Gigabit Ethernet, they want to use it for the same address length, same frame format, and the maximum and minimum frame length also, so that only the complication will goes to a physical layer, so it can allow the MAC layer, which can allow only the full duplex only. It won't accept for half duplex communication. So 1000 base SX short wave, long wave, that is a fiber with SW, fiber with 1000 base LX, long wave, and then 1000 base CX, which is going to have a shielded twisted pair cable with a very less distance, it is the 25 meters, and 1000 base T4 unshielded twisted pair cable with 100 meters of distance, which will have a 4 cables. Rest of all the 3 methods which is going to use only the 3 wires. But the first two, the 1000 base SX short wave and long wave range only, which can able to have an fiber optic cable, so that the maximum distance is going to be a 500 meters as well as 5000 meters, it can able to adopt it. The rest of the functions, because we know that which is going to accept only the full duplex mode, there is no half duplex mode. All the cable communications are going to be a full duplex only. Next we will see that 10 gigabit Ethernet. So extend the technology, they want to use it for extend that technology, and also they want to extend it for a data rate as well as the coverage distance. The coverage also they want to extend it. So the first thing is extending the technology, extending the data rate, as well as extending the distance. So here the Ethernet can be used as LAN and MAN. So they want to use it for both a local area network as well as metropolitan area network. So 10 gigabit Ethernet can be used it here. So the MAC will allow, we know that 1 gigabit Ethernet also, which is going to support only full duplex mode. But here also the MAC will allow one step ahead, which will allow only the contention free services. It means that free to use for any radio signals also. So the types are going to be a 10G base SR short range, and 10G base long range, and 10G base extended wave, and 10G base X4, as if similar to an gigabit Ethernet. Only thing is that the data rates are going to support at a greater extent. It means that the 10 folds of 1 gigabit Ethernet connections. So here all these, because it is going to have a higher data rate, so all the mediums whatever we are going to use it here is only the fiber optic cable. There is no support for a unshielded or shielded twisted pair cable. But here one thing is that we can notice that the 10G base LR and 10G base XEW, that is a long range as well as extended wide range, which can able to cover for 40 kilometers range also. But the number of wires also, it is going to be only 2 wires, and with the encoding mechanism is going to be a 64B, 66B, and SONET. Synchronous optical network communications also can be used in a 10 gigabit Ethernet implementations. So hope you understood the concepts. So let me recap that whatever we have discussed here. So first we have discussed what is an Ethernet protocol and what is the basic functionality of an Ethernet protocol, and then what is a frame format of an Ethernet protocol. And then we saw that what are all the evolutions, what are all the generations of Ethernet. First we have seen that the standard Ethernet protocol, fast Ethernet protocol, gigabit Ethernet protocol, and 10 gigabit Ethernet protocol. And each protocol, each Ethernet protocol, first we started with a standard Ethernet. So how the standard Ethernet protocol which works, and what are all the different implementations and how it works. And then fast Ethernet, how the speed has been increased without changing anything. So that is where the fast Ethernet can be achieved, and what are all the changes has happened in the physical and MAC layers. And then fast Ethernet, what are all the different implementations, that also we have discussed. And then from the fast Ethernet, how 1 gigabit Ethernet protocol has been evolved, and what is the change we have made, only which is going to support for a full duplex alone. There is no support for a half duplex communication. That is where the Gigabit Ethernet, that is a 10 folds of fast Ethernet. And then we have seen some of the implementations in a 1 Gigabit Ethernet. At last we have seen that 10 Gigabit Ethernet. So it is also 10 folds of 1 Gigabit Ethernet. So, and also we have discussed about 4 methods. But in 10 Gigabit Ethernet, we have used only the fiber optic cable. But earlier, whatever the Ethernet methods, we have used unshielded and shielded twisted pair cables also has been used. I hope you understood the concepts. If you have any questions, please give it in our comment line. If you don't subscribe to my channel, please subscribe to my channel. I'll keep posting many videos related to ICT technologies as well as the computer networks. Please support to my channel. Thank you for watching my class. Thank you once again.